Hello everyone. Today we're going to be taking a look here at Chapter 12. We're going to start with Lesson 2. Talk about surface areas of prisms and cylinders. So our objectives: find lateral areas and surface areas of prisms, and then find lateral areas and surface areas of cylinders. Okay, so let's get through a few definitions here. The faces are the sides of a prism. The faces that are not bases are the lateral faces. We call those the lateral faces. And of course, technology. Pen's not working. All right, we call those the lateral faces. These are the sides that are not the bases. Okay, lateral faces intersect at the lateral edges. Okay, lateral faces intersect the bases at the base edges. Base. Okay. The altitude is the perpendicular segment that joins the base planes. Okay, so the altitude is perpendicular to both base planes. And the height is the length of the altitude. The height is the length of the altitude. So here we can look at this right prism, which we'll use more often than not. We'll use right prisms. That is, that they're perpendicular. You can see lateral edges. Lateral edges are where the lateral faces meet. Base edge, that's where the lateral face meets the base. Okay. The bases here, this is a hexagonal prism. So whatever type of prism it is, the base will be of that shape. So this is what we call a hexagonal prism, where the base is a hexagon. You have two faces that are both hexagonal. All of the lateral faces you can see are just rectangles here in a right prism. All right, so the altitude, also of note, the altitude is perpendicular to the base, so you could measure any of these lateral edges and they'd be perpendicular to the base. So we're going to check the lateral area. We're going to find the lateral area of a prism here on this next example. And to do that, we will, let's back up. Oh, we can get back, we can get to this part of the notes. Okay, the lateral area, we need to do this before we go on to the next problem. The lateral area is the sum of the areas of the lateral faces. So just take each lateral face. If we look at this hexagonal prism, there is 6 lateral faces. Okay, and add up the area of each lateral face. Okay, in this triangular prism, where the base is a triangle, you have 3 lateral faces. All right, and so the way to find the lateral area of a prism is L equals perimeter times the height. Perimeter times the height. Okay, so find the lateral area of the prism. This is a triangular prism, so find the perimeter of the base. Find the perimeter of that base. We will need to find that hypotenuse distance. So 5 squared plus 6 squared, this is the Pythagorean theorem, would give us x squared. 25 plus 36 equals x squared. So the hypotenuse would go square root of 61, square root both sides, and we get that x is 7.8 centimeters. Okay, so then we should be able to find, because again, if we're finding lateral area, that's perimeter of the base times the height. So lateral area, perimeter of the base, add all the sides together, 7.8 plus 5 plus 6, that is 18.8. 7.8, the hypotenuse plus 5 plus 6. perimeter of the base, and then we're going to multiply it by the height. The height of the prism is 7, so 18.8 by 7, 131.6. Lateral area is 131.6. This is an area, so that is centimeters squared. All right. This next one, word problem. We're probably going to have to do a little bit of drawing here. The length of each side of the base of a regular octagonal prism is 6 inches, and the height is 11 inches. Find the lateral area. So again, lateral area, perimeter of the base, P times the height. So let's think about what the base would be. This is a regular octagonal prism. So the base would be a octagon, 8-sided. It's regular, so each side is the same. So 8 sides, all of length 6 inches would be 8 times 6. The perimeter of the base would be 48 inches. The height, we're told, is 11. So the lateral area would be 528 inches squared. Okay. So let's talk about surface area then. The surface area of a prism is the sum of the lateral area and the area of the bases. So you're just going to find the lateral area and the area of the two bases. So you can use surface area equals lateral area plus 2b being the area of the base. Or, of course, you can take lateral area, perimeter of the base times height. So you want to find the area of all the lateral faces, which is lateral area, and then you're going to add 2 areas of the base. So let's take a look here. Find the surface area of the rectangular prism. So call one of these rectangles the base. Let's highlight with green. Let's call this rectangle here a base. Would mean this other end would also be a base. So that'll be our base, and then all the other rectangles there are lateral faces. So to find surface area, we need perimeter of the base times the height of the prism, that's lateral area, plus 2 times b, which is the area of the base. So surface area. Perimeter of the base, again, the base is these green rectangles, so we'd have 4 plus 6 is 10, plus 4, 14, plus 6 is 20. Perimeter of the base is 20 feet. Height of the prism would be 9. So that takes care of my lateral. That takes care of my PH part, lateral area. Plus 2 times B. B is the area of the base. The area of a rectangle is length times width. So B in this problem will be 6 times 4, which is, of course, 24. So plugging this all in, we get a surface area. 20 times 9 is 180, plus 2 times 24, 48. So we get that the surface area is 228 square feet. Okay, that's the area of each surface combined there. All right, and so find the surface area of the triangular prism round to the nearest tenth. So again, you're using the idea that surface area is perimeter of the base times height plus 2 times the area of the base. So again, this is a triangular prism, so here the base is triangular. So the base is this triangle, this right triangle. And so to find the measure of the hypotenuse, which we will because we need perimeter of the base, then we go, 12 squared plus 12 squared equals c squared, hypotenuse squared. So 144 plus 144, so 288 equals c squared. The square root of 288, 16.97 would be the hypotenuse of that right triangle. So surface area, perimeter of the base, 12 plus 12 plus 16.97. That's the perimeter of that triangle. Times the height of the prism is A, plus 2 times B. B is the area of the base. So again, this base is triangular, so the area of a triangle, we're going to substitute for B, 1/2 base times height, so 12 pi 12. So half of 144, which is 72. Okay. So surface area equals 12 plus 12, 24, plus 16. You can kind of plug it all in your calculator at once, or just, order of operations, parentheses, multiply. That's correct. Okay. So just plugging this in, times 8, you get 327.76 plus 2 times 72, 144. You get a surface area of 471.76 millimeters squared. All right, so that's how you find surface area and lateral area of a prism. Now we're going to take a look at a cylinder. Okay. The axis of a cylinder would just be canned goods and things like that, have cylindrical shapes. The axis of a cylinder is a segment with its endpoints at the center of the bases. So the bases here, of course, are going to be circles. So the center of the circles are connected with the axis of the cylinder. Again, we'll use right cylinders in here. We won't look at oblique ones very often, or at all, we should say. The surface area of a cylinder is the sum of the lateral area and the area of the two bases. So here they've kind of deconstructed the cylinder. You have two bases, two circles are your bases. And if you think about peeling a label off of a bottle or something, if you do that, that label is going to be rectangular in shape. This measure would be the circumference of the circle because it wraps around the circle, 2 pi r, and the height would just be the height of the bottle or the cylinder. So, of course, this piece represents your lateral area. These are your bases. Okay, so let's go on with a couple cylinder problems. Lateral area formula, surface area formula. Find the lateral area and the surface area of the cylinder. Round to the nearest tenth. So lateral area pi times diameter of the base, which is 15, times the height, which is 18. So 15 times 18 times pi. 848.2 millimeters squared. That is lateral area. Surface area equals lateral area, pi times diameter times height. Plus 2 pi r squared, the area of a circle, times 2. All right, of course, let's substitute r. So we were given the diameter was 15, so the radius would be half of that, would be 7.5 squared. So substitute your radius. So plugging all of this in, you get 1,201.7 if you go to the nearest tenth millimeters squared. So that's surface area. All right. I'll leave this one to you guys. Kind of an interesting problem, so you guys can go ahead and give that one a shot. All right. Thanks for watching. Have a wonderful afternoon.